In our previous module, we have discussed about how we can calculate confidence interval for mean, and now in this chapter, we'll discuss how we can calculate confidence interval for proportion. As I was saying, in the chapter, we will discuss about how we can calculate confidence interval for proportion. Therefore, we'll first discuss like what is proportion, and then we'll see how we can calculate confidence interval for proportion. And to conduct an experiment, sometimes we also need to know like what should be the desired sample size, and we will see how we can determine that. So let's first try to see what you basically mean by proportion. So what is proportion? So proportion represents the fraction of something, of a desired quality, of a desired characteristic or something, right? And we denote the population proportion by P, and the sample proportion is denoted by P hat. Then the formula for the proportion is R over N, where R is the specific characteristics, that something should have, and N is the sample size. As for example, say we are interested to know what is the proportion of female student at Sam Houston State University. Then what is the R? So say now we consider a sample. We took probably some of the student from the university, not all the student, right? So these some of the student are our sample, and now in this sample we count the number of female student. Here R is the count of female student in the sample, and N is the sample size, like total student that we have considered, right? Then this ratio of these two is basically our proportion. Now I think it is clear to all of you like what do you mean by proportion and how we define that, right? And our goal is to estimate about the population proportion P using this sample proportion, right? Earlier we have seen how we can calculate confidence interval for mean, and now we will see how we can calculate confidence interval for proportion. So this is very similar. So now for this formula we have P hat here, which is the sample proportion, right? And since now we are dealing with proportion, we are calculating confidence interval for proportion. So now instead of using sample mean, we have to use sample proportion, right? And plus minus the margin of error. And how we define margin of error for calculation of the sample proportion? So here this is the formula for the margin of error. So here this part is the critical value, right? That comes from the standard normal distribution. And what does the alpha over 2 means here? So alpha basically is the level of significance. We have discussed that, right, in our previous chapter. So alpha is the level of significance. So for the 95 confidence interval, what is the level of significance? 5%, right? And since on the left side we will have now area is 2.5%, since it is two-sided, and on the right side as well we will have 2.5% area, right? So that's basically indicate that. So this is the critical value that comes from the G table, standard normal distribution, and this is the standard error. So here we are dealing with proportion. So this is the sample proportion, and this part is the critical value. N is the sample size, you already know that. Then the formula for the standard error is that, right? So this part is the standard error. So now I think it is clear to all of you like how we can calculate confidence interval for proportion. So in the chapter we will only discuss about how we can calculate confidence interval using G approximation, and when like we cannot use G approximation, we will not cover this case like in this semester. Probably if you take like advanced course in statistics, you will learn that then. So now let's see when we can use G approximation. So when n times p hat is greater than or equal to 5, and n times q hat, or 1 minus p hat is basically same as q hat, right? Or n times q hat is greater than or equal to 5. So both of them has to be greater than or equal to 5. In that case we can use normal approximation, right? In that case we can use normal approximation, and we'll only cover these cases like where we can apply this, right? Where basically our conditions satisfy these conditions. In that case we can use G approximation, and we'll only cover this like in this semester. So let's look into that with some example. As for example, here our sample size is 500 and x is 260. So x, imagine like we are dealing with the we are interested to know the proportion of female student at Sam Houston State University, and we took a sample of 500 student, and among this 500 student we have 260 student female student, right? Therefore the proportion p here is 0.52. After the calculation you will see like the proportion would be like 0.52. And how we'll calculate that? It is basically 260 over 500, right? So that will basically give you the proportion, which is 0.52. We'll discuss that later. So in that case, the condition that we just want to check, we'll discuss about that later, how we can calculate proportion. So the condition is n times p has to be greater than 5, right? So here n was 500 and p, we have seen the p was 0.52. Therefore in that case n times p is 260, which is greater than 5, right? And n times 1 minus p hat, which is also in that case greater than 5, right? Which is 240. So which is also greater than 5. Therefore in that case the condition is satisfied. So in this kind of situation we can use normal approximation, right? But if this condition, these two conditions are not satisfied, then we cannot use normal approximation, and in our course we will not cover that, right? Even though like we will not cover like when we cannot use the approximation, but let me just mention like in which situation we shouldn't use the approximation. So when the sample size is very small, in this kind of situation we cannot use normal approximation. And when the p values like the value for the p, that means the proportion is very close to 0 or very close to 1, in this kind of situation we should not use like g approximation. And when the distribution is also very skewed, in this kind of situation we shouldn't use g approximation, because we know like normal distribution is symmetric, right? So if the distribution is very skewed, then in that kind of situation we shouldn't use normal approximation, because in that situation normal approximation doesn't give us very good result, right? So now let's try to look with an example like how we can calculate proportion, how we can calculate confidence interval for proportion. So as I was saying, imagine like we are interested to know like we are interested to calculate the confidence interval for the proportion of female student at Sam Houston State University, and we took a sample of 500 student, and the number of female student among the 500 is 260, right? So how we'll be calculating the proportion? So first we can calculate the proportion by taking the ratio of the female student over the total student, right? So then 260 is the number of female student, 500 is the total number of students, so that gives us 0.52. Therefore in that case the sample proportion is 0.52, right? And then like we know like what is the critical value. Say we are interested to calculate like 95% confidence interval, then the critical value associated with 95% confidence interval is 1.96. You can check the G table to find this value, but you can also remember that because we mainly use confidence interval, we mainly use like 95% confidence interval, 90% confidence interval, and 99% confidence interval. So you can remember those values, and you can also check like G table, like how you can find this value using the G table. And then standard error. So that was the formula for the standard error, like square root of p times q over sample size. So in our case the sample size was 500, p was 0.52, therefore q would be like 1 minus 0.52, which is 0.48, right? And that's give us the standard error. So in that case our standard error is that. And then by using the formula that we have discussed earlier, like here we have the proportion, then plus minus the margin of error. So what is the margin of error? Margin of error is basically the critical value times the standard error, right? So in our case the standard error is that, and for the 95% confidence interval the critical value is 1.96, right? So therefore the confidence interval that we find is that. And how we interpret that? We tell like we are 95% confidence that the true proportion of female student at Sam Houston State University lies between 47.6% to 56.4%, right? So now I think it is clear to all of you like how we can calculate confidence interval for proportion, right? So let's talk about some of the conceptual thing associated with this confidence interval or like margin of error. So you already know like this is the margin of error part, right? In the confidence interval, this is the critical value and this is the standard error for sample proportion, right? So we have already discussed that in our previous chapter as well. Like the higher the confidence level, the larger will be the value for the margin of error, right? So the higher the confidence level, the larger the value for the margin of error. And as the sample size is large, as the sample size increases, then the margin of error decreases. So here you can see, if you look into this formula, if we have a large sample size, then you are dividing this part, right? So therefore the margin of error will be smaller, right? And the variability, when we get the maximum variability, so when the value for the proportion is 0.5, in that case, we get the maximum variability. So you can see here, so this part basically determines the variability here. So this part determines the variability. Now let's see when it is maximum. So if the value of this is maximum, then in this situation the variability would be maximum, right? So now let's see when it could be maximum. So assume like when p equal to 0.5, in that case the p 0.5, so q would be like 1 minus p, right? And the multiplication of them is 0.25, right? So when p equal to 0.5, in that case q is also 0.5, and in that case the p times q is this, right? 0.25. And imagine like any other case, as for example, say our p is say 0.3. In that case p is 0.3, then q is like 1 minus 0.3, which is 0.7, right? And the value here is 0.21, right? So you can easily see like 0.25 is greater than 0.21, right? So in that case, like we can say like when the p is 0.5, then we will get the maximum variability, right? So those are the some of the confidence interval that we commonly use and their corresponding critical values. So we often use like 90% confidence interval, and in that case the critical value we use is 1.645, and for 95% confidence interval the critical value is 1.96, and for 99% confidence interval the critical value is 2.576, right? So those are some of the common confidence interval and the critical values that we use. And I have also discussed earlier, like the higher the confidence interval, the higher the confidence, the wider the interval, right? And therefore we will be like less precise in that case, right? I think it is clear to all of you by that time. Suppose we want to conduct an experiment and we do not know like what is the desired sample size we need for this experiment, and then we can use this, we can just rearrange this formula to get the desired sample size. So this is the formula for the margin of error, right? So if you just take the square on both sides and then rearrange, then this is the formula for the sample size. And we already know where like q hat is basically equal to 1 minus p hat, and g is the critical value in this formula. We already know that, right? And e is the desired margin of error, right? So as for example, say if we have p hat equal to 0.5 and q hat equal to 0.5, and say our margin of error that we are dealing is like 0.05, imagine like in that case, then for 95% confidence interval, like you can usually use like 95% confidence interval for the calculation of the sample size, and we know the critical value associated with that is 1.96, right? And then by plugging like all this value here, you can calculate the desired number of sample size that we need to conduct the experiment, right? So you can see here like this is the critical value, so this is p, this is q, and this is the margin of error, right? And if you plug in all of this value like in this formula, you'll basically get that, and then you can calculate the desired level of sample size, right? So in the previous slide we have calculated the sample size using this formula, and for the calculation we have used like sample proportion. But the thing is that when we do not have the sample, then how we can calculate the sample proportion? How we know like the sample proportion, right? The question is that in practice, in fact, we do not know that. And this is why, like, for the calculation of the sample size, we use like the prior studies related to these topics, and from the prior studies, like, we can find the value for the p, for the proportion, and we use this value for the calculation of the sample size. So that means in this formula, like, we replace the p hat with the prior p that we have for from some experiment, right? And but even if we don't have any experiment, in that case as well, we can calculate the sample size. And in that case, for the p, we use the value 0.5, because 0.5 give us the maximum sample size, right? We have seen that like earlier, like when the value of p equal to 0.5, in that case we have the maximum variability, and therefore we get the maximal sample size, right? So when we do not know any information about the proportion, and we do not have like any prior studies related to this topic, then in that case we use the value 0.5 for the proportion, and by using 0.5 we calculate the sample size, right? So when we do not have any information, then we choose the case where we can get the maximum variability. So when the p is unknown, then for the p we use the value 0.5, and for the q as well, therefore the value would be 0.5, because q is like 1 minus p, right? And then that would be the sample size. Then this is the formula for the sample size. Then for desired margin of error, say in that case our margin of error is 0.5, and usually like we calculate the sample size using like 95% confidence interval, or like you can also use like any other confidence interval, like that's also fine, like 99% confidence interval or so, but the usual case is 95% confidence interval. Therefore then in this formula we have the critical value, and this is the margin of error, right? And this is basically the value for p times q, right? 0.25, and we get the sample size 385 in that case, right? So now I think it is clear to all of you, like when we do not know any information about the p, then how we can calculate sample size. So to summarize, what we have learned today, we have learned like how we can calculate confidence interval for proportion, and this is the formula that we use to calculate the confidence interval for the proportion. And to use this formula, the condition that has to be satisfied is like n times p has to be at least 5, and n times q also has to be at least 5, right? And we have also discussed like as the sample size increases, then the margin of error become smaller, right? And we have also discussed like how we can calculate the sample size using this formula to conduct an experiment, right? So that's all for today.